Clear all? Let us solve some more problems on maximum power transfer theorem. The problem statement is find the value of load impedance. Find the value of load impedance when maximum power is transferred to it. That means if you want to transfer maximum power to this, what should be this value? So after finding that, you have to find how much power is transferred to it. That means you have to find maximum power transferred also. So since this is your load impedance, let us mark the load terminals as A and B for your reference. Now, when you are solving any problem on maximum power transfer theorem, first you have to convert the given network into Thevenin's equivalent circuit across the load terminals. So Thevenin's equivalent circuit means a voltage source V Thevenin in series with an impedance Z Thevenin. Because it is an AC network, you have to find impedance, not resistance. So keeping the load terminals as it is. Step 1. To find V Thevenin. So what is V Thevenin? V Thevenin is nothing but the open circuit voltage across the load terminals. So this is your load terminals. You have to find the open circuit voltage across it. To find the open circuit voltage, you have to create the open circuit. If you want to create open circuit, we should remove the load. Okay. Now the procedure is remove the load. Remove the load. Okay, I have removed the load. Create the open circuit. Created the open circuit. Find the voltage between A and B. That is your V Thevenin. So how to find the voltage? Either you can go for KVL or KCL. Suppose if I solve by mesh analysis, you have two loops here. This is, you can take it as loop current I1. This you can take it as loop current I2, and you can solve. So let us take this loop current as I1. Let us take this loop current as I2. Apply KVL and solve. So applying KVL to loop 1. What is KVL to loop 1? Left hand side, sum of all the voltage drops. Right hand side, algebraic sum of voltage sources. So 5I1 plus J10 I1 is equal to what? Moving clockwise, negative to positive is positive. For the voltage 100 at an angle 0. 100 at an angle 0 is nothing but just 100 only. That gives 5 plus J10 into I1 is equal to 100. So what is I1? 100 divided by 5 plus J10. Now keep the calculator in complex mode, enter this value and find the value of I1. Then you will get the answer as I1 value 8.94 at an angle minus 63.43. So if you find this value, you will get the answer for I1 8.94 at an angle minus 63.43. Next, I should apply KVL to second loop. Applying KVL to second loop, apply KVL here. 7I2 okay, minus J20 I2 minus J20 I2 is equal to what? Moving clockwise, plus 2 minus 100 at an angle 0, nothing but 100 only. We get 7 minus J20 into I2 is equal to minus 100. Then what is I2? So I2 is equal to minus 100 divided by 7 minus J20. Again, keeping the calculator in complex mode, enter this value as it is. When you are entering, please put the brackets properly. Then you will get the value of I2, that is 4.71 at an angle minus 100.9 3 amps. So, this is your I2 value. You check the answer in your calculator. So, you get the I1 value and I2 value. Once you get I1 and I2 value, your intention is to find Thevenin. Thevenin is nothing but voltage between the terminals A and B. Now, potential of this point, let us take as VA. Potential of this point, let us take VB. So, Thevenin can be written as VA minus VB, taking this positive, this negative. Okay. Now, what is Thevenin? Thevenin is equal to VA minus VB. I want to measure the voltage at this point. I want to measure the voltage at this point. Then if you take the difference of those 2 points, you get Thevenin. This is very simple concept. To measure the voltages at any point, as I said earlier, we should have a reference point in the circuit. So, let us take the reference point as this point itself. If you take this as reference point, then what happens to VB? VB becomes 0. Now, VB becomes 0. Therefore, what is Thevenin? Thevenin is equal to VA. That's all. So, what is the potential of this point with respect to ground? I should find. This point is same as this point. Okay, both are same points. To measure the voltage at this point from the reference, you should have 3 paths. You can go by this way. You can go by this way. You can go by this way. You can also go by this way. Whichever the way you go, you will get same answer. If you want, you can check it. So, I will prefer to go by this path to measure the voltage at this point. When you are measuring the voltage in that path, you should know the polarity of voltages. So, polarity of voltage drops depends upon the direction of current. Already you have assumed the current direction I1 and I2. Accordingly, write the polarity first. So, I2 is flowing like this. I2 is flowing like this. Hence, this is positive, this is negative. Voltage drop means positive to negative is drop. Current is flowing from positive to negative. Again, current is flowing like this. Hence, this is positive, this is negative. Once you write the polarity of voltage drop, easily you can write the equation for VA. Now, VA is equal to what? Is equal to what? You move from the reference to this point. Go like this. Plus 2 minus is minus 7I2. Plus 2 minus is minus 5I1. So, minus 7I2 minus 5I1. This is the equation. Any doubt here? Go like this from the reference. So, plus 2 minus is minus 7I2, plus 2 minus is minus 5I1. You know the value of I1 and I2, substitute here. Okay. Now, substituting I1 and I2 here. So, gives VA. Please substitute first I1 value here and I2 value here and get the value of VA entering in calculator. So, what is the value you are going to get? Final answer is 71.67 at an angle 97.2. Please check the answer. So, VA after substituting the value of I1 and I2, keeping the calculator in complex mode, you get the value of VA is equal to 71.67 at an angle 97.2 or 29, I hope. Please check it. This is what your VA. Therefore, this is nothing but Thevenin is equal to VA 71.67 at an angle 97.29. So, this is your open circuit voltage for this network. Now, after finding Thevenin, what I should find the second parameter? I should find Thevenin. How to find Thevenin? Again, looking into the same open circuited terminals, load terminals, you have to find the total impedance of the network. To find the total impedance, what you should do? You have to make all the independent sources in the network 0. Anyhow, you have only one independent source, that is voltage source. It is made 0 by creating short circuit. Now create the short circuit, rewrite the circuit, find the total impedance of the network looking into the load terminals. Step 2 to find Z Thevenin. Step 2 to find Z Thevenin. So Z Thevenin is nothing but what? Total impedance of the network. So you have to find looking into the open circuited terminals, that is your Z Thevenin. To find Z Thevenin, what is the procedure? You have to make all the sources 0. So you have a voltage source. This voltage source is made 0 by creating short circuit. By creating short circuit, you have to find the total impedance of the network. Now let us find the impedance. So these two are in parallel, 5 parallel with J10, then 7 parallel with minus J20. Okay. So these two are in parallel, these two are in parallel, 5 plus J10, 5 parallel with J10, 7 parallel with minus J20 across A and B. Again simplify this and simplify this. Again these two are in series. Then find the final value that gives Z Thevenin across A and B looking into the terminals. You will get the answer as 10.23 minus J 0.182 ohms. So this is what the value of Z Thevenin. So keep the calculator in complex mode, get the answer for this and this, and add both because these two are in series. Then you get Z Thevenin value as 10.23 at an angle J 0.182. So you got Z Thevenin. Then what is the next step? Next step is you have to write Thevenin's equivalent circuit. Now let us write Thevenin's equivalent circuit. Step 3. Step 3, Thevenin's equivalent circuit. What is Thevenin's equivalent circuit? Thevenin's equivalent circuit is nothing but a voltage source V Thevenin in series with an impedance Z Thevenin. Okay. Then substitute the values here. Then connect the load across it. Connect the load across it. This is what the load terminals A and B. Now connect the load across it. Let us connect the load here. What type of load is given? It is given ZL. So load is given as ZL. Now what type of source it is? It is AC source. It is AC source because you got V Thevenin 71.67 at an angle 97.29. Okay, AC source. This is source impedance is what? This is source impedance, that is nothing but Z Thevenin is also complex. And what type of load is given? Load is not given, you have to find. Okay. Now what is the condition for maximum power transfer? Source is AC. Source impedance is complex and the load is ZL, that is impedance load. So condition for maximum power transfer is the value of load impedance must be equal to complex conjugate of source impedance. It is case 3. Whatever we derived earlier, it is case 3. Source is AC, source impedance is complex, and the load is impedance load. Hence the condition for maximum power transfer is the value of ZL must be equal to conjugate of ZS. Okay, what is ZS here? Here ZS is equal to Z Thevenin. That is equal to what? 10.23 23 minus j 0.182. This is your Zs. I want Zs conjugate. Therefore, Zl should be equal to Zs conjugate. What is the conjugate of this? Take opposite sign. That gives 10.23 plus j 0.182. So, this is the value of load impedance for maximum power transfer for this problem. After finding the load impedance, I should find the power transfer to load also. To find the power transfer to the load, I should find first current. Once you get the current, then I can find the power. Okay, now let us find the load current. IL is equal to Ohm's law, V Thevenin divided by Z Thevenin plus ZL. That is equal to V Thevenin value, you know, 71.67 at an angle 97.29 divided by Z Thevenin is 10.23 minus j 0.182 plus ZL. What is ZL? 10.23 plus j 0.182. Okay. So, here this get cancelled, and what you are going to get, IL is equal to 71.67 at an angle 97.29 divided by 10.23 plus 10.23. Now, again we can keep the calculator in complex mode, enter this value as it is, or you can divide these two and keep the angle as it is normal. Then you will get 3.503 at an angle 97.29 ampere, means 71.67 divided by 20.46. If you do, you will get 3.503. Keep the angle as it is. This is your load current. After finding the load current, what you should do? You have to find the power P max. Let us find now P max. What is the maximum power transferred? Is equal to IL magnitude you should take, because it is AC and you have the angle here. I should consider only the magnitude of current. So, square into the load. So, here you have a load impedance. This can be written as RL plus J XL, suppose if you write like this. So, this is your resistive part of the load. This is your inductive part. Always power will be consumed by the resistive part of the load. Power consumed by a pure inductor is 0, that you know already. Hence, when you are writing the power equation, you must write I squared into RL, not ZL. That is, this is the RL value, I squared into RL. Should not write I squared into ZL. So, I squared, that is 3.503 is your magnitude into, what is the RL value? 10.23. Then find the power. How much you will get this power? Get 125.52 watts. Enter this in calculator. You get the answer for power is equal to 125.52 watts. This is what the power transfer to the load. So, what we did, if any problem is asked on maximum power transfer theorem, first convert the given network into Thevenin's equivalent circuit. That is a voltage source in series with an impedance, if it is AC network. If it is a DC network, a voltage source in series with a resistance. After obtaining that, you connect the load across the Thevenin's equivalent circuit. So, here in this problem, load was given as ZL. Therefore, condition for maximum power transfer, you know, that is, when source is AC, load is ZL, the condition for Pmax is the value of load impedance must be equal to complex conjugate of source impedance. This is your source impedance. Conjugate means we take opposite sign. Then you will get the value of ZL for maximum power transfer. Once you get the value of ZL, then to find the power, find the current. Once you get the current, to find the power, we should use only the magnitude of current into, that is current square, into the value of load resistance. You have both RL and XL. You have to take only the load resistance, because power is dissipated only in the resistive part of the load. So that will get the maximum power. So this is how to solve the problems on maximum power transfer theorem. Thank you, one and all.